So hey there guys, we have thus far looked at a lot of separation techniques, 9 to be particular. However, none of these separation techniques describes a means for separating two or more liquids that are completely mixable. At this point, the technique termed distillation comes in handy. Now, distillation as a separating technique is used in the separation of two or more liquids that are completely mixable. There's a catch here though. The liquids must boil at temperatures that are far apart. In essence, they must have a wide boiling point difference. Now, some of us might begin to wonder what boiling point means in the first place. It is that temperature at which the molecules of a liquid have acquired so much energy that they change to the gaseous phase. Now, this property is the primary reason for the separation of liquids by distillation. Now, let us assume we have a mixture of water and ethanol. Ethanol is the primary constituent of your beer, wine, and your methylated spirits. It is important for us to note that distillation is a suitable method for this separation because the mixture consists of two liquids that are thoroughly mixable, as you can see. The liquids also have a boiling point difference that is wide. By wide, I mean above 10 degrees Celsius. We know this because we know that water boils at 100 degrees Celsius, while ethanol boils at 78 degrees Celsius. That these conditions have been satisfied guarantees us that distillation is suitable to carry out this separation. Let us get right to the process of distillation. First of all, a setup akin to that displayed in this image is made. In the image, we can see a thermometer and a condenser. These are the primary apparatus used for this separation. After the setup has been made, with our mixture to be separated already placed in the round bottom flask carrying the thermometer. Now heat the mixture. As the temperature begins to rise, the mixture gets hotter, isn't it? Recall, ethanol boils at 78 degrees Celsius, while water boils at 100 degrees Celsius. So as the temperature rises to about 78 degrees Celsius, the ethanol acquires sufficient energy and changes to the gaseous phase, leaving the water behind in the mixture. The ethanol gets to the condenser, which has the primary function of changing the gaseous ethanol back to liquid phase and is immediately turned back to ethanol liquid, which is then collected with another flask. Meanwhile, the water remains alone in the round bottom flask as the temperature would not have gotten to 100 degrees Celsius, so it neither boils nor changes to vapor, leaving the mixture separated. I'm sure that the next time you mistakenly pour water in your gallon of methylated spirits, you will employ the distillation procedure and separate them without much hassle. See you in the next lesson.